This is question number 5 in the 9231 paper 1 2018 May. So this is a series summation question. It's given that Sn is equal to sigma r equal to 1 to n minus 1 to the power r minus 1 times r square. Now using this result, standard result for sigma r equal to 1 to n r square, we need to prove that S2n is equal to minus n times 2n plus 1. So first let's see what is sigma r equal to 1 to n r square. So we know that the standard result for sigma r equal to 1 to n r square is equal to 1 by 6 n times n plus 1 times 2n plus 1. Now let's start the problem. It is given that Sn is equal to sigma r equal to 1 to n minus 1 to the power r minus 1 r square, right? Now let's try to put the values of r here and let's try to write what is S2n is, okay? So S2n will be equal to, I'm just putting the values of r here. So when I put the values of r, I'll get minus 1 to the power 1 minus 1, that is 0, into 1 square, plus minus 1 to the power 2 minus 1 into 2 square, plus minus 1 to the power 3 minus 1, 3 square, plus minus 1 to the power 4 minus 1 into 4 square. This is how it goes. So what do I get here? I get 1 square minus 1 into 2 square plus positive 1. This becomes positive 1 times 3 square minus negative 1 times 4 square. So minus 4 square plus etc. We do have an alternate plus and minus in this. So S2n is equal to, and you have alternate plus and minus, you can write S2n as sigma r equal to 1 to n r square, 1 to 2n r square minus 2 times sigma r equal to 1 to n 2r the whole square. Now this is a standard result. When you substitute the values of r here into this equation, and when you simplify that, you will get this back. That you can check if you want. So S2n can be written in this way when you have alternate positive and negative. So S2n is equal to sigma r equal to 1 to n r square minus 2 times sigma r equal to 1 to n 2r the whole square. Now I can further simplify this. Sigma r equal to 1 to 2n r square minus 2 times this 2 square I can take out of the summation sign. So it becomes 4 sigma r equal to 1 to n r square again. So this 2 times 4 will reduce to 8, right? So I'm writing 8 sigma r equal to 1 to n r square. Okay. What is the standard result for this one? Sigma r equal to 1 to n r square can be written as 1 by 6. Since it is 2n, in this equation, wherever you find n, you have to be substituting it with 2n. So 1 by 6, 2n times 2n plus 1 times 2 times 2n plus 1. Wherever you find n, you have to substitute it with 2n. Okay, that's how you do it. Since it is, summation is from 1 to 2n. That's why you do this. You substitute n with 2n. So r square, sigma r equal to 1 to n to r square can be written as 1 by 6 2n times 2n plus 1 times 2 into 2n. So that is actually 4n plus 1. Okay. That is what we get for the first summation, minus 8 times sigma r equal to 1 to n r square, which is the same result, 1 by 6 n times n plus 1 times 2n plus 1. Now I'm going to simplify this part. Okay, so let me just rub the first few steps. Yes, so on simplifying this, 1 by 6 times 2n can be written as 1 by 3 n times 2n plus 1 times 4n plus 1 minus 8n by 6. So that reduces to 4 by 3 n times n plus 1 times 2n plus 1. Fine. So that is equal to, I can take 1 by 3 n to n plus 1 from both the terms, right? So I'm taking out 1 by 3 n to n plus 1 as a common factor. So what is remaining is 4n plus 1 minus 4 into n plus 1, or 4 times n plus 1. On reducing that further, I get 1 by 3 n into 2n plus 1. Now we are simplifying this bracket inside. So 4n plus 1 minus 4n minus 4. 4n plus 1 minus 4n minus 4. 4n minus 4n cancels. 1 minus 4 reduces to negative 3. Okay. So I get 1 by 3 n times 2n plus 1 times negative 3. Okay. Though that negative 3 and positive 3 gets cancelled. And finally I get negative of n times 2n plus 1, which is what we got. So hence the proof. So this is how you do the first part of the question number 5. Now we are moving on to the second part of the question. Second part of the question is like this. Find the value of limit n tends to infinity s2n by n square. So this is very simple. Just have to substitute the value of s2n that you got now. So limit n tends to infinity. S2n is negative n times 2n plus 1, right? Divided by n square. Again, further simplifying it, limit n tends to infinity. I can open the bracket and multiply in the numerator. So that becomes negative 2n square minus n divided by n square. I can split this fraction as minus 2n square by n square minus n by n square, right? I'm going to cancel the n square terms. So limit n tends to infinity, negative 2 minus 1 by n square, right? Minus 1 by n. That's how it reduces, minus 1 by n. Now I'm going to apply the limit. When n tends to infinity, minus 1 by infinity, this entire term becomes 0. So our answer is negative 2. That's the value of limit n tends to infinity, s2n by n square. Now finding the value of limit n tends to infinity s2n plus 1 by n square. So what is s2n plus 1? Limit n tends to infinity. s2n plus 1 can be written as minus n into 2n plus 1 plus 2n plus 1 the whole square. So this entire thing is divided with n square. Opening the bracket, simplify it. So you get minus 2n square minus n. I'm sorry, you don't have to do this. I'm going to take out the 2n plus 1 out, common, from both these two terms. So what is remaining in the bracket is negative n plus 2n plus 1, which is divided with n square. So I would get limit n tends to infinity, 2n plus 1 by n square. And in the numerator we have 2n minus n is n plus 1. Now you can split this. So limit n tends to infinity, 2n by n square becomes 2 by n plus n by n square is 1 by n plus 1 by n square. So the first term is 2n by n square plus 1 by 1 into n is n. N by n square is 1 by n plus 1 by n square. Oh, I made a mistake. I think 2n plus 1. This reduces to I'll just do this once again. I'll get this bracket reduces to 2n minus n is n plus 1. So I'll get 2n plus 1 times n plus 1 by n square. We get 2n by n square plus, so this is what we got, 2n plus 1 into n plus 1 by n square. Now let's open the bracket. So 2n square plus n plus 2n plus 1, which is divided with n square. So now we're going to split it. So we get n square by n square, we get a 2 here. Now for the rest of the terms, when you apply n tends to infinity, when you apply the limit, you get everything as 0. So the final answer is 2. So for the first one, the limit value was negative 2, whereas for the second one, the limit value is positive 2. So this is how you do this. Question number 5, part 1 and 2.